that I leave the mic to you and Julian at the end to give a concluding word. Okay.
Thank you, and welcome to the last session, and most exciting session always comes last. So thanks for your patience. Now, this is an interesting topic which we are planning to cover today, which is public blockchain as payment infrastructure. So my name is Sudhir. I'm representing Capgemini, and along with me I have Cédric from Tezos, Pietro representing Algorand, and Henri, Starkware. Soon they will have their session and presentation about themselves and what they're doing in this space, followed by we have Q&A, the usual pattern. So before I hand it over to the individual sort of sessions, I had few comments I thought to begin with, which probably helps us to think about some questions as we go forward. So we heard a lot about CBDC, stable coins, blockchain for the last 2 days, and I don't want to bore that with the last session as well. But if you look at the evolution of blockchain, probably 2008 onwards, and if you look at evolution of payments, it's over 40 years. So there's a lot of things have evolved in the payment systems, right? So the question obviously comes, what's the readiness for us to embrace a public blockchain for payments infrastructure when so much already has happened in payment industry? I like the quote which I captured with one of the guys who said, the payments is all about 3 zeros. So it is zero cost or minimal cost, zero touch, and zero time for processing from a consumer standpoint. Now, can we achieve these in the current context of blockchain? That would be one of the questions I have. And as well, I was thinking about payment is not just a transaction anymore, right? So if you look at the 5 things that I captured, it's the ecosystem of third parties that are being developed around payments, which is wallets, remittance players, super apps, which is a big thing in Asia, if you have seen that. Growth in commerce, online and commerce, which is pretty much during COVID and now post-COVID. Value-added services is a big part of payments, loyalty, BNPL now mostly right? So on-the-spot finance and things like that. We also hear quite often from cards player now using blockchain as technology for things like request to pay, mandate management, and those type of things that are coming into VAS or value-added services. Technology in payment is not necessarily only blockchain alone, right? So we'll have to look at the role of data, artificial intelligence, IoT, and various other mechanics that comes into payment. So basically, advancement in technology, increased expectation from consumers, and regulatory scrutiny are the 3 things that are driving payment industry today. So we have to weigh in today's conversation of public blockchain in the context of all these things when it comes to payments. So that's how I would rather start. So let me start with Cédric yourself. Please walk us through Tezos and what you do, and then we keep the presentation 15 minutes each. And once we finish all 3 presentations, we'll come back to the questions. Thank you.
So thank you, Sudhir, for this introduction. Hi, everyone. I'm Cédric. I'm responsible of the adoption of the Tezos blockchain in France. We are an R&D entity specialized on the development of the Tezos blockchain. We are almost 80 now, and we onboard a lot of research on this entity. And my role is to promote the Tezos adoption and to onboard different kind of entities like startup, entrepreneur, institution, private companies. So first, to begin, what is Tezos? Tezos is a public blockchain, so anyone can interact with this technology and with this infrastructure. And the rules are defined by the user because it's a blockchain designed to evolve with its own governance protocol. Like Ethereum and Bitcoin, it's a public, so anyone can deploy a node or can deploy a smart contract on Tezos. And what is really interesting is this fact that it's designed to evolve, and since 4 years, the Tezos protocol has evolved 9 times, and now we are building the next amendment, and the next amendment will deploy the feature of layer 2 and roll-ups. So we will bring more scalability to the Tezos protocol. And it's a great example for the future of money, and also for bringing payment infrastructure for blockchain. And also, it's a proof-of-stake protocol. This means this protocol is very eco-friendly because we have made a study since the last of the 2021 year. And this protocol consumes only 17 European households in a year for several million of transactions each year. So in terms of payment use cases on Tezos, we have a different use cases about crypto payment, like a day-to-day mean of payment on NFT marketplace, on decentralized finance protocol also.
Sorry, can you clarify what's public about the public blockchain is generally a public, right? I can download the blockchain data from Bitcoin, Ethereum, and so forth. So yours is more public than that, or?
No. It's the same way as Tezos is a public blockchain, but we have heard a lot of things about permissionless or about private blockchain, but I would like to be sure that for everyone, Tezos is a public infrastructure. So
as opposed to private.
Yeah, okay. But
yeah.
So, but the typical one that you think of are all public, right?
No problem.
Okay, yes,
so in terms of CBDC, we have made some exploration with the Banque de France. I will be in depth on this subject after. We also deployed some stablecoin on Tezos, an euro stablecoin. And the programmability of the smart contract has a huge advantage to deploy direct payment. So the first one, I would like to introduce you a use case from a company called Lizzy. It's a French one. And this company is building a platform for instant retail payment solution, and they are building an application with an exchange, a crypto exchange asset, and also with a meaning of payment, because they are dealing with their own cryptocurrency exchange called Zebitex, and they also have a wallet directly on their platform. They just launched their own token on the Tezos blockchain called Easy, and this Easy token is the core token for all the ecosystem, and it's for consumer and merchant. It's to give exclusive advantage and reward for the using of this application. So, and they are deploying since few weeks an interesting initiative in the Beaugrenelle market center since few days, and they have deployed a crypto gift card to onboard more and more mass adoption in terms of crypto payment. The second use case is about Banque de France. So we work on several projects with Banque de France around CBDC and also around tokenization of financial assets. The first use case was with La Société Générale Forge. It's a subsidiary specialized on crypto assets for the Banque Société Générale. And it was to implement a financial product on a blockchain. As we said, tokenization of crypto, of financial asset. And we have to represent it with token, what we call them security token. And the goal of this project was also to set up on a public blockchain a digital euros and to study what we call the operation of delivery versus payment, what is quite very important in the blockchain technology. And also it was here to test the scalability, the speed, and the security of this kind of exchange between CBDC currency. The next project on Banque de France was to transfer a digital euro on a private on a private blockchain on Tezos. So they build their own infrastructure to test some exchange between each bank central. So there were like 27 nodes on the private Tezos blockchain. And it was just to see the fast of the network and to try to explore in which way the cost and the speed will be more efficient on the Tezos blockchain. And the last project was more or less the same as the second, but they would like to bring more privacy on the second project. So they deploy saplings technology, and saplings technology is using zero knowledge proof technology to bring privacy between transaction and between each part of the bank central. It's current now. It's not. It's more or less done because they are more exploring this project since 2 years. So
uses the Tezos protocol.
yeah, but the France is using Tezos protocol for exploration, but they also use other protocol.
And it's an EVM friendly protocol.
No, it's different. So after that, I will talk about a nice project back for the group, the Casino retail group. So it's a project of digital stablecoin euro-backed, which is a digital asset according to the next MiCA regulation and also to the PACT law in France. So it's a stablecoin collateralized 100% in a bank account in Société Générale in France, in Saint-Etienne exactly. And they are audited each month by the group Deloitte. And their objective is to facilitate crypto payment by democratizing an audited stablecoin. And they are providing their services around different topics. So, for example, they are available on off-ramp solution like Vert, MoonPay, on NFT marketplace like Rarible, and you can also buy Lug on CoinHouse. It's a PSAN entity in France, and also on Montpellerin. It's a broker in Switzerland. And they are providing their service also in DeFi platform, but I think it will be in weeks or in a month, like we can see here. And their goal is to be more or less the Circle of tomorrow. But I have seen just yesterday, Circle is launching his own his own stablecoin euro. So we will see in a few months. And the last project is about directed payment. So MoneyTrack is a startup based in France. It was deployed with a former employee of Edenred. And the project of this payment platform was to launch, was to eliminate the third party in directed payment. So they use the blockchain technology, the Tezos blockchain, to facilitate the exchange between the entity on healthcare. So because in healthcare, in healthcare industry, you have the healthcare entity, you have insurer, and you have insured. And all these entities are not very trust between them. So they use the Tezos technology to have more traceability and to transfer money more easily and with a stronger traceability. And that's why they use Tezos technology. And just to go further on this presentation, it's not use case built on Tezos, but I think it's very interesting to talk about it. About cross-money transfer, for example, called remittance. This industry was always been dominated by companies like Western Union, but new players are trying to make the scenario more competitive since a few years. And the blockchain provides a massive potential to solve it. For example, we have an entity under NDA who is about to launch a credit card in United Arab Emirates, because nearly of 60% of the workforce here doesn't have credit card and doesn't have a bank account for now. but they use the service of Western Union, and it charges between 8% to 12% for each transaction. So that's why blockchain could reduce a lot this cost, and I think it could be great for this employer to use the blockchain technology. About also financial inclusion, during the last presentation, they talk a little bit about effectively the Bitcoin could have a strong interest. We have seen in Salvador and also in other countries in Africa. This is now a state money, and it improves access to banking and financial services for Salvadorian people by using mobile banking, and it improves access to financial services. And the last one, I talk a little bit about that, but we have a nice example about CBDC in the little country called Bahamas. They use $100 CBDC, and they use it because it's a country made by Iceland, and they have a lot of difficulty to transport money, and it costs a lot. So that's why it will be more efficient for them to use CBDC. And they also is a country subject to hurricane. So CBDC can improve the way to distribute the money for them. So thank you.
Thank you, Cédric. Before I call, you can start, but I just had one quick question. Because looking at your clients, you have large banks you have already started to work with who are regulated industry, and you talk about public blockchain, which is sort of in the opposite direction for a regulated industry. So how are you able to convince, what is your value proposition for you to secure all these sort of work?
I have thought about projects with Société Générale, but we have another one with BNP, but they are exploring more and more public blockchain, but because at least deploying private network will be not efficient for them because they need to bring more liquidity on the market. And if you would like to have liquidity, you need to be public and you need to be interoperable between each commercial bank in France, but also in Europe or also in Asia. So that's why for them it's really important to test public blockchain.
We'll now hear from Pietro, Algorand.
Very good. Thank you. I don't know if my presentation is in. Very good. Pietro Grassano, I take care of business solutions, which essentially is business development within Algorand blockchain protocol. We have 3 legal entities, the Algorand Foundation that is based in Singapore, the Algorand Inc. that is based in Boston. You will see why. Our founder is Professor Silvio Micali, that is a teacher at the MIT. And Algorand Labs, by the way, called exactly like Nomadic Labs, based in Rome, that is more, if you want, the service company, the development company. Yeah, I mean, the way we tend to characterize what blockchain is not necessarily related to the coin itself. Also in the previous presentations, there was also a little bit the mix, which I think is perfectly rational, between the infrastructure and the token, the coin and the rails, because the two are two sides of the same coin, if you wish, right? Because the elements of incentives for the miners, validators on the blockchain are what keeps the blockchain afloat. And also is an element that needs to be taken into consideration in that theta variable, trying to understand what is the benefit from the utilization of the blockchain. The way we characterize Algorand is that it's an infrastructure for the representation and the transaction of value in the digital age. As simple as that. In the presentation, I will try to give you a couple of elements of why we think Algorand is different, which are the technological elements that set us apart. Some of those primitives can be implemented, in our opinion, for payments, and we have some use cases that go exactly in that direction. Algorand was founded by Silvio. Silvio is Turing Award. He invented zero-knowledge proof, probabilistic encryption, and the verifiable random function among some of the primitives of modern cryptography. The verifiable random functions are used at the core of the engine of Algorand's blockchain. What is the engine of a blockchain? Is the consensus mechanism. Is the way in which you can actually select who will propose and who will validate the next block of transaction in the distributed ledger. And the team, I think, is pretty impressive in combining best of academia and best of enterprise. That's the way they put it more often than not. Of course, Silvio, I can mention Chris Pakert as the head of cryptography, as the father of lattice-based cryptography, that is the most promising field of post-quantum computing. And actually, centralized or decentralized, I think that infrastructure for value need to think now about the post-quantum world. Paul Milgrom will talk to many of you. And of course, it's in order of intelligence, and you see that I am in the last row after Silvio and so on and so forth, right? Why did we need to create Algorand? Because we were not happy with the previous approaches. Vitalik Buterin, the founder of Ethereum, mentioned the fact that in blockchain you, more often than not, experience what is called the blockchain trilemma. The fact that it's hard to have scalability, decentralization, and cryptographic security together. Well, the anecdote is that Silvio heard him in a conference, asked him, well, is it a theorem or is it a heuristic finding? He answered, well, it's very honestly, it's a heuristic finding. Okay, I will try to write the theorem for you. While trying to do that, actually, he demonstrated the opposite, and essentially the white paper of Algorand was starting to exist. Of course, scalability limits, proof of work. Proof of work has scalability limits that are actually, they say, a feature of the protocol more than a limitation. But then, how can you do payments if your transaction takes 10 minutes to be confirmed? Okay? And then, of course, yes, it's a feature in the sense that you need to demonstrate that you've been working in order to keep the network secure. Of course, the family of proof of stake came afterwards as consensus mechanism, as a tool to decide who can validate the next block in the chain. Proof of stake tells you essentially that you have to have skin in the game in order to be allowed to validate the next block in the chain, and misbehaviors will be somehow punished. There are some families, bonded proof of stake, delegated proof of stake, delegated proof of stake. Hey, we select the same amount of, say, 21 delegated that are going to be always the same. They are honest people, and they will remain honest forever. Yes, sure, they will remain honest forever. They are exactly a surface of attack for a malicious agent in terms of both IT attack, hacking attack, partitioning the network out from those 21 agents, and also a surface of attack for a corruption attack, right? So we don't believe in delegated proof of stake. Bonded proof of stake, you need to collateralize your role as a validator with some amount of money. Fine, there is a sort of element of incentive, but there is also the road, the vector for an external attack via the collateralization. So we don't believe in bonded proof of stake either.
For delegated proof of stake, you don't need to keep the same committee all the time. You could draw new committees by using proof of stake.
You did exactly what others did to you. Going just one page afterwards, I will tell you what is the invention that Algorand brings to the table. Hey, like in the ancient Republic of Venice, the judges, the official roles were selected via a sortition, essentially. The idea is, well, let's utilize that cryptographic primitive that Silvio invented, the verifiable random function, at the core of the consensus mechanism in order to select in a pseudo-random manner a committee of nearly 1,000 validators. And in this way, they essentially become unknown to anyone until it is too late. So until the moment in which they will say, hey, I won the lottery, I'm one of the validator, and yes, I validate in the same message, they will have to say, yes, I validate, or no, I do not validate the next block in the chain, okay? Through the utilization of the random function that Silvio invented.
So how long are these? Are they all validators? I mean, are the validators?
How
You can explain that.
I will get into, no, so this is the first pillar, the verifiable random functions at the core of the consensus mechanism. This increases elements of efficiency, which is, if you want, the scalability aspect of a blockchain. At the end of the day, every infrastructure has the characteristics of having to be efficient in solving a problem, otherwise it doesn't get an infrastructure. And we can calculate this in terms of transaction per second. We do 1,200 transactions per second as we speak. It's going to go up for a factor of 10 by the end of the year. In terms of time of finalization of the block, that I think is what you were asking, how long does it take to do
the 1,000 validators,
Yep.
is their turnover even of that over time?
every 4.4 seconds?
I see. Okay.
Because the time of finalization of the block is 4.4 seconds. In those 4.4 seconds, there will be the verifiable random function, the broadcasting of the messaging, the understanding if the majority is thumbs up or thumbs down, and then, of course, appending the new block to the chain. Okay? So this increases scalability because the secret is that the verifiable random function is a very succinct piece of code that can be broadcasted very quickly in an asynchronous blockchain protocol.
What's the overall pool from which validators are chosen? So that
It's everyone that has a single algo in his pocket because the verifiable random function is embedded into each unit of the algo and is online. You need to have one algo and be online.
So if I have one algo and I'm online, I should check every 4 seconds to see
It is made automatic in the sense that, and of course it's verifiable by everybody, right? Because the validation is essentially a process in which you want to be sure formally that that transaction doesn't represent a double spending transaction.
So it's purely algorithmic validation in some ways. I mean,
If you wish,
unless
yes.
I find some code.
It's not political.
Well, right. I mean, even the malevolent agents would have 4 seconds time, right, to come up with code to.
Exactly. They would, yeah, the only thing they could do is actually try to partition the network. But the other pillar, the overall architecture makes us partition resistant, okay? So again, let's stick to the first pillar, the consensus mechanism. Low fees. Actually, we do not experience congestion. I will come back in that. We have transaction fees that are just related to the role of being an anti-spam. We don't want to have zero transactions and bots sending to each other zero transactions just for the purpose of charging the chain of a useless workload. It's mathematically demonstrated that the probability of soft forks is 10 to the minus 18, which is the number of, if the protocol of Algorand was validating 1 block per second, and actually we are validating 1 block per 4.4 seconds, would be the number of seconds from the start of the universe until now, which seems to be a pretty decent number to say there is instant finality. Yes, please. Sure. But they may not be online in the sense that you need to be online, okay? But it can be automatized, yes, because it's a formal control, okay? Then, this not existence of soft forks allows to have instant transaction finality, okay? instant transaction finality is, I think, one of the most important features if we are talking about payments. If you need to wait 6 minutes or, I don't know, 1 minute before knowing if your payment went through, it's going to be hard to move the queue at the merchant at an appropriate pace, right? Then you don't have delegation or buying of the stake. You don't have a minimum stake, which means that it's really decentralized. Anyone with one single algo can participate potentially to the consensus mechanism. And efficiency turns also on the fact that, again, we did probably the same type of exercise that Tezos did, a pretty thorough exercise in estimating the carbon footprint of the whole system, and knowing that a node of Algorand runs on a Raspberry Pi because it doesn't require strong computational power, and making some assumptions on the nodes that we know and on the nodes that we do not know, we came out with a process for which we buy carbon offsets from a carbon offsets marketplace in order to more than compensate the minimum carbon footprint that Algorand systems have. So carbon negative. Secure with respect to denial of service, network partition and resistant. Again, the consensus mechanism based on the logic of the verifiable random function increases the security on one end because you don't know whom to attack until it's too late, and it increases the scalability at the same time because it's a process that is very quick and very brief and very immediate. Then there is a second pillar, and the second pillar is an architectural one. One thing is the engine, the other thing is the layout of your machine. The layout here, the architectural choice that we did was to create a smart contract language in the layer one. So as close as possible to the ledger, within the ledger, we have a smart contract language that allows to create stateless smart contract, not necessarily Turing complete, because you don't want Turing completeness in the ledger, but that allows to have primitives like the creation of tokens, like the atomic transactions, transactions where the transactions happen on an all or nothing basis. Whether I have the assets or you have the assets, one of the two will have the asset, okay? But there is no situation in which the asset is on a table somewhere exposed to counterparty risk and so on and so forth. So this is feasible because we've been syncing those primitives into the layer one as close as possible to the registry, okay? Tokenization happens in the layer one. And it happens in the layer one with the ability to have role-based access controls when you are minting a token. Role-based access controls are our way to say to the market, hey, you know what, AML, KYC, CTF is doable, is manageable when you are creating an asset, a token, a payment token, a well-regulated stablecoin, a security token on Algorand's blockchain. Because it's true that blockchain is pseudonymous and not anonymous, right? But it's also true that you need to find ways, cryptographical primitives, in order to be able to quarantine specific accounts during the investigation, to force the transfer of an asset, to have a whitelisting, blacklisting type of model, again, to enforce KYC and so on and so forth. To have flexible reserves. You may want to have a reserve and that token doesn't go outright immediately 100% in the market, okay? You can manage off-chain asset documentation, the prospectus of a mutual fund, the ISDA contract of any complex financial instrument. And so this to us is one element. And you see where I'm going, right? So I'm going in the direction of saying that these features are exactly what can allow the implementation of permissioning on a public blockchain. We remain public in this case, then we can do private instances exactly as my predecessor was saying, but there are the logics of permissioning at the asset level that can, in order to be implemented, be combined with identity logics, and therefore represent a sound infrastructure for the transfer of value. The atomic transfer, again, the fact that a transfer is truly atomic, it doesn't need additional cryptography because it's baked into the layer one, and therefore happens on an all or nothing basis. You don't need hash time locks. You don't need to have complex smart contracts in order to enforce a truly atomic transfer. Is pretty unique to Algorand. We can do group payments, we can do distributed payments, and so on.
Can you explain, you know, I'm completely ignorant. Atomic transfer means what?
Like in Greek, atomos. I don't cut the atom, right? It means that the transaction happens on an all or nothing basis. So when there is a transaction, like in the analog world, right, transactions happen on an all or nothing basis. I come with the money, you come with the asset, and in the same moment, we exchange. And this is an atomic transaction in the sense that it cannot be separated, cannot be cut.
It means that the delivery of the good happens at the same time?
Exactly. The trade is the settlement.
Yeah, that's right.
The trade is the settlement.
Pietro,
Okay? Atemno. Sorry.
Pietro, maybe you can speed
Be a
up
bit
little
quicker.
yeah.
Okay.
Pietro is, by the way, available for drinks. You can go on with Algorand
Especially.
for a few hours after
Thank you,
the...
Sudhir. Okay, then other type of smart contracts, rekeying. If you have a private key that is compromised, it's easy for us to create a situation in which the public address remains the same, and so the identity remains the same. Smart contracts are key for programmable finance. My thesis is that this is the key aspect, right? So the permissioned digital asset and payments can happen on a permissionless infrastructure. The police chases the thieves on a decentralized, permissionless infrastructure that is the motorway and the roads system. They don't need to redo the motorway or the road every time they are creating, so they are chasing the thieves. And they do not get less centralized as an institution if they are using a decentralized infrastructure. So my idea is let's separate a little bit the concept of infrastructure from the concept of institution that, no, as you demonstrated, is so important in the considerations. These things, role-based access controls, with instance finality, with partition resistant, with obfuscation techniques, and I think that my successor will talk about obfuscation techniques, can make the Algorand blockchain a way to avoid a little bit the separation and the polarization between what is centralized and what is decentralized. Hey, we know life is both centralized and decentralized. Reality is a combination of both things. What we want is to create an infrastructure that is secure for people, that allows institutions to do their job, that allows traceability in a way that centralized systems do not allow, with the respect of privacy that centralized systems do not allow, by the way, via cryptography, in order to fix a little bit some of the problems of what we call legacy infrastructure, that is the centralized financial infrastructure. Again, it's legacy in the sense that before inventing the concept of blockchain, there was no other way to represent value than in a series of centralized databases. Okay? The logic here is a little bit different. Let's try to see if this is true or not. Very quickly, a few use cases. Stable coins that want to be regulated. Circle asks for a US banking license, by the way. I'm not sure if everybody is aware. 6 Clover's global payment rails. BNext, they do remittances. We were talking about remittances before between Spain and Latin America in a very regulated manner. Monerium does e-money, euro e-money, okay, with a Buffin stamp out of Iceland. Bloom is a payment orchestration platform, so many use cases that have been using
Pietro,
those
I'm
features.
sorry, I will
That's done.
stop. Yeah.
Bum, bum, bum,
Thank
bum.
you.
That's it. So essentially, the idea is the centralized infrastructure can improve the effectiveness of centralized
I
institutions.
have to do an atomic transfer now. Okay, all right, thank you so much. Sorry about that. Okay. Yeah, as Henri will go next, but as you start your presentation, one question to you, Pietro, is, there will be multiple public blockchains as payment structure. So how will Algorand protocol interoperate in such scenario?
He cut me in order to give me the microphone. Something interesting. So interoperability. Okay, we've been hearing about interoperability before, and it's a major element if you want to do an infrastructure, decentralized infrastructure, you actually are not necessarily in favor of the fragmentation of the market. And yet what we see is that there are 2,000 blockchain, different protocols, and so on and so forth. So interoperability is key if blockchain wants to succeed as an infrastructure. I think that technology has the answer somehow. We came out with a concept that we call, which has been implemented and should be out during the summer, that is called state proofs. State proofs is a set of, we call them Falcon keys, quantum-resistant cryptographic signatures that allow not only to sign on events on the chain, but also on the state of the chain. And this is going to be an element, let's say a building block, the building block of any decentralized token bridge. You want to interoperate without a centralizer, because otherwise you just miss the point of the blockchain system, right? You want to interoperate via decentralized token bridges, because you want to interoperate the asset, the representation of value between one chain and the other. And this technology is going to be available. It's going to be available between Algorand and any other chain, and between any other chain between each other. Okay, so it's going to be open. Voilà. State proofs.
Thank you.
Hello. Hi, so my name is Henri Lieutaud. I work at Starkware. And today I'm going to talk to you about validity proofs and how they can scale blockchains and how they can be used specifically for CBDC. I'm a developer advocate for StarkNet, which is a product I'll talk about in a sec. So just a quick show of hand here. Who considers themselves an economist? Okay. Who considers themselves a computer scientist? Okay. Who's developer here? Okay. Cool. So I'll try to explain these concepts, which are fairly mathematical and everything, but I'll try to describe them in a shallow sense that makes sense. Don't hesitate and ask questions later on if you have them. So let's start with what validity proofs are in a nutshell.
The economists would prefer the math.
I didn't hear you.
The economists would probably prefer the math.
I'm not sure you'd like this kind of math, this math, but...
No, absolutely. No, I'm serious, right? I mean, just as a communication device, we use the mathematical models a lot. And
Cryptography also?
Pardon?
Cryptography also, you're comfortable? Cool. This is not the talk I prepared for, so I'm not going to do it, but happy to talk about it later on.
It just makes it so much easier to understand math and...
Cool. So, validity proofs, what are they and what do they allow? So let's start with the first question. Why are blockchain expensive and why don't they scale that well? Well, basically because in the traditional world where you're making a transaction, you have one party computing the result of your transaction, right? It's your bank. It's done by one party, and in exchange, you're trusting them, right? They provide a service, and you trust that they're honest, and they're computing how much money you have on your bank account in a reliable way. That's what we call delegated accountability. You delegate the accountability to your account to a third party. Blockchains, on the other end, are what we call inclusive accountability. Every time there's a transaction on the blockchain, every node of the network validates whether it's his or somebody else's. And here, you have a first instinct as to why transactions in the blockchain context are expensive. When a sum of work is done by one party or by 10,000 people, obviously it costs more money when it's done by more people, right? And that's in a nutshell why blockchains don't scale. We call often blockchains distributed ledgers. They're not distributed at all. They are replicated. They're replicated ledgers. Everybody does the same work at the same time. It's extremely inefficient. So now the question is, and this obviously limits scalability, right? Figure this. We're all going to a restaurant, and we're all ordering food, and some people are paying, some others are not. And at the end of the night, we all want to pay for just what we consumed. And we all agree on the rules we should follow to calculate this amount. The way it works in the traditional world is that Daniel will compute the balance of everyone and tell everyone, you need to pay this. You need to pay this. And you trust him. You trust that he's reliable, that he did not make a mistake, and that he did not give himself more money. The way it works in the blockchain world is that all of us will take all the receipt and recompute all the bills of everyone, which is extremely inefficient, right? And you don't have time to do that when you're out of the restaurant. Validity proofs essentially enable Daniel to run the computation, to calculate who owns what, and to produce an output saying you own that much money to that person, associated with what we call a proof, which is a set of cryptographic value that anyone can verify to check that he did the calculation correctly. And this verification process is way easier to do than calculating the whole bill for everyone. So for a small cost per person, you get the same trust assumption as if everybody had done the same amount of computation, right? So going back one step, in a computational system, how would it work? You have an entity called a prover that executes a program, and that is able to prove that he executed that program correctly. So he will output the output of the program as well as the proof, and you have an entity that is a verifier that is able to verify that proof. Here's where this gets interesting. Blockchains are able, in their smart contract, to verify such kind of proofs. So this means that for the first time, you have the ability in a blockchain to verify computation that was done outside of the blockchain. And you have a way to verify it that does not rely on trusting humans. It relies on pure mathematics. And that's extremely powerful. So the way we use that Starkware in the blockchain context is we have a prover that operates a specific blockchain, and the execution of such blockchain is committed regularly and verified regularly by a public network, which is Ethereum in our case. So this gives extremely strong assumptions and very high guarantee on the fact that we're not cheating. Think about it. If you have a mathematical proof that I executed the computation correctly, you don't care whether I'm French, North Korean, or a central bank, right? Or just a pet shop owner operating a node on the side. So that's pretty cool. You don't need to trust the operator.
If the inputs and the outputs have to be on the blockchain though, I mean, maybe the computation is done outside.
You don't really need it. What you just need is the validation that you went from state A to state B correctly.
But how do you know state A and state B if it's not on the blockchain?
Yeah, that's a specific problem called the data availability problem. I'm not going to get into it, but basically you have two solutions. Either you store the data in a place everybody can see it, which in our case is Ethereum, so a public blockchain, or you figure that this data can be saved elsewhere, so maybe a bunch of us host it on our data center and we consider that this is safe. This is what we call Validium. Yeah, in that case, that's the hash of the data.
So
yeah.
there's a hash of the data on the blockchain?
You could do that, for example. We store the data on chain because we want very strong security guarantees. So now, a proof doesn't fail. It's either true or false. It's kind of like a hash or a signature. It's true or false. then, so if basically we say, look, we're moving from state A to state B, here's the proof, and this proof is not valid, the transaction is not going to go through in the smart contract. So the smart contract is going to say, I'm sticking to state A. And it's going to wait until there's a valid proof going from state A to state B. Just like if you submit a block, an invalid block in Bitcoin, it just doesn't move forward.
So there's one prover and multiple verifiers?
There might be various provers and multiple what we call sequencers. Verifier, technically Ethereum is a verifier, so every node in the Ethereum network is a verifier of StarkNet. Pretty cool. Anyone operates its own ETH node here? No, okay. Ah, nice, someone at the back. No, that was a joke. Okay, so now let's talk Starkware, StarkX, StarkNet. So who are we? Starkware, we're an Israeli company. We're about 80 people. Part of our team, we have a strong background in academia. One of the founders is Eli Ben Sasson, who came up with the Stark protocol. And we have actually a big number of people with big brains also, me not included. And we have now people in Europe, yours truly. And we came up with basically 2 products. We came with a bunch of others. We don't talk about them anymore because they failed. So, but these 2 stuck, so that's cool. So the first one is StarkX. The second one is StarkNet. StarkX is basically a white label trading engine secured by the Ethereum blockchain. Initially, when we started developing computation proof, the first thing we came up was a provable programming language, which is called Cairo, which basically allows you to execute arbitrary program and prove them. And the first application we came up with is, hey, you know what, let's write Coinbase, but verifiable. So instead of depositing money to an account of Coinbase, you deposit it to a smart contract. And then all the operations of the exchange, all the operations of the backend are verifiable by Ethereum. Pretty cool, right? And this had tremendous success. It was used by very big projects such as DYDX, Sorare, Immutable. DYDX has lowered the cost of operation for its users using ZK rollup, so storing the data on-chain by 500 to 1,000 times, right? A few weeks ago, StarkX did more transactions during a week than Ethereum, their underlying network, during the same week. And other projects such as Sorare, Immutable, have been able to reduce the cost because they're using off-chain data storage, so they don't store it directly on the chain, and they reduce the cost for their users by 20,000. Let me repeat that, 20,000. They're at the point where basically network fees don't matter. So they are able to pay the network fees for the user, and they offer a much better user experience. So StarkX has been a very big success, but you know, it's a trading engine. You can do way more things with the blockchain. So we're currently developing StarkNet. StarkNet is a generalized purpose smart contract platform that is secured by Ethereum. So you're able to write your own smart contract on top of Ethereum, design your token, your governance, emit NFTs. You can do whatever you want, really. We recently achieved feature parity with Ethereum. So anything you want to do on Ethereum, you're able to program it on StarkNet. And right now we're focusing on throughput and decentralization. By the end of this year, we want to be able to process 10 times the amount of transaction of Ethereum at 1% of the cost. And we also want to have a clear roadmap to being decentralized. Right now, the network is not, because it's operated by us. You know, when you develop a product, it's easier if you operate it yourself, but then we want to decentralize it. So now, yeah.
Verifier. So you leave that part to the Ethereum network. Does that require computation, gas fees?
Yeah, sure. So basically every time, so let's say we generate a proof for each 100 block on StarkNet. Every 2 hours, we're going to send a transaction to Ethereum with the proof, and the proof is going to get verified by Ethereum. So there's a cost associated in gas. The idea is that when transactions occur on StarkNet, we collect a fee that is then used to pay for the fees to secure on Ethereum.
And it's typically valid. You can cover that cost.
Well, I mean, right now, we're decentralizing this, so we're not really focused on that. But yeah, the idea, of course, is that being the sequencer will be something where you get paid for your work. Kind of like mining. You know, you operate a big machine to service something for the network, and you get paid for that. Basically, what we do is to execution of smart contract what mining does for the security of the network. It allows the network to outsource execution in a trustless manner. all right? And we want sequencers to be decentralized and anyone to be a sequencer. Now, I have, yep.
I still try to understand exactly what's going on, on your, whatever in your network, right? So imagine that we, few of us go together, we use your network, we deposit data token just in a roll, like in a roll-up, right? And then we do interactions with one another. And some of the interactions that we have with one another are contingent on something that happens in the real world. So like I buy a car from somebody, for instance, right? And so then, we do this repeatedly over and over, and at some point we try to settle, right? We can try to verify, and then the verification comes back as it didn't work. Something went wrong, right? So whatever it is, if your proof is false, now what?
I'm not sure, like, the analogy to what you're saying is what happens if Bitcoin fails and there's no block and transactions don't go through. We hope it doesn't happen, and technically the rules are the same for everyone, so it should not happen. But like basically, the going from block 0 to block 100 follows a certain set of rule. If your transaction follow these rules, then the operators of the network will be able to generate a proof. And there's no way that your transaction is valid and the proof is false.
No, what I'm trying to say is, in the process of using a network, I incur costs, for whatever it is that I do, right? So there's some interactions that we do. Say you have a trading system, I
Sure.
trades, I have trades, I make commitments. I'm just trying to say, if there's, for whatever reason, so, normally you have like, I think an optimistic rollup is actually a punishment mechanism. If somebody, the processor does something wrong, their stake gets withdrawn. So you seem to have nothing of that nature. That's what I'm trying to say.
No, because there's no way you can cheat. That's the thing. Like when you use an optimistic rollup, there's some dude computing everything on the network and saying, hey, this is what happened and this is the result. And if he cheats, and the network will say, well, okay, I have no way to verify it, so I'm just going to wait for somebody else to verify it. And if somebody says that he's cheated, then I'm going to punish him, right? That's what happens in a rollup, in an optimistic rollup. Does that make sense? Now, in our case, the person doing all the computation will generate a proof, and when he will say to the network, hey, look, here's the result, the network will say, oh, okay, I have a way to verify that this worked correctly. And if it did, then the network is valid, and the proof the transaction went through. I'm going to talk about quickly because I have 20 seconds left, so I'm going to take 2 minutes more just to present these slides to explain how we can use that in a CBDC context and in a permission systems, basically. So the first thing is that what you get with that is hyper-scalable throughput. Currently, StarkX is able to operate 10 times more transaction than what is done on Ethereum. And there's no reason why we can't go further than that in terms of purely execution trading engine. Soon we'll have something we call recursive proving, which is basically, you operate a network and you prove that you executed it correctly, and verifying the proof is much easier than doing the work. If you're able to do that one layer above, then you're able to condense a lot of network in a trustless manner, in a single proof, on a single chain. And so this will allow having way more throughput because it allows parallelization of proving of the network. So in our case, and once we have recursion, you could have a CBDC network, right, which is operated on StarkNet, settled on a public network, and it could have various sub-branches, okay, sub-networks, such as Visa, MasterCard, whatever, and they operate in a trustless manner, and they can prove to the CBDC network that they operated according to the rules of the CBDC network. You get full data protection and execution control. If you operate your own chain, or if your users operate their own chain, they can choose KYC, AML, if they censor transaction or not, how much can transaction cost, and you also get to choose if the data is public or not. As we mentioned earlier, the data can be on a public chain, or it cannot be, and maybe if you want to operate your own chain, you don't want the data to be on chain, but maybe you still want to prove that you operated correctly. So that allows you that. It allows to prove to the regulator that you operated correctly without disclosing the data to your competitors. You could also have a CBDC as a custom-based layer. You could have some blocks on the CBDC that are dedicated blocks, KYC, DeFi, credit scoring, and all banks, payment processor, directed payments inheriting from these applications. all of this in a trustless manner. And all of this condensing to the same proof based with mathematics. Ultimately, what will happen? That's just conjecture, right? That's my opinion. Ultimately, you need a credibly neutral network. So CBDCs, turns out they want you to trust them. They don't really trust each other. I mean, they need guarantees, which makes sense. So they will need some kind of mechanism, some kind of network where they can coordinate with each other without fearing the network being altered by anyone else. So probably what will happen is the architecture I described will just happen one layer above, and you'll have a public entity somewhere, a public network, and various CBDCs coordinating on the public network. They'll get to choose who uses them on the public StarkNet. They'll get to offer this particular private infrastructure for all the citizens in their jurisdiction. Now, is it all a dream? Will it actually happen? Yes and no. Yes, it will happen because the infrastructure is there, the technology is there, and yes, there is a possibility that this is not speculation. All the tech is here, and some form of this will emerge. No, it won't happen because it won't be CBDCs. CBDCs are not technical operators. They're not capable of maintaining a network, and so I personally don't think this will happen. I think this will happen just like it's starting to happen in the United States, that the private sector will do all these things. You will see banks running their own chain, their own roll-up that is validated on the main chain. You will see stablecoin emitters using this kind of systems and building private environment where people will build on top of it, and you already see this kind of stuff. Look at what Binance Smart Chain is doing. That's a version of that. What Kronos Chain is doing, that's some version of that. And basically, CBDCs will happen, but probably not operated and initiated by central bank payment. Sorry, I sped through this. Happy to take a few questions.
Looks like a good conclusion for the day two, right? We started with CBDC and ending with thank you. Yeah,
we could pick another one, but recently I asked some guy, why do you, like, he was doing NFTs, and I asked him, why do you use Ethereum? It's expensive. He said, yeah, but that's where the party's at. And that's where most exchanges happen, where most of the volume is, but we sure could go to another chain.
I had the same question. I was just about to propose you can talk to Pietro and get into Algorand.
Happy to.
By the way, Silvio invented zero knowledge, so should come home.
Okay, I think we have run out of time pretty much, but if you have one or two questions, maybe we can open up, and maybe two questions.
One question to anybody is really, for example, if you look at Amazon and Netflix, right? Can you hear me? I mean,
yes.
Let us say the rent we pay them, right, is all moved to a blockchain, right? Is there a way to kind of lend it? So, for example, I have a subscription. I should have the power to lend it to a third party because I've paid for it. But the blockchain today is fair to say is not evolved to handle that. Is correct?
I'm not sure I understand your question. Sorry.
Let's take Netflix, right? So I have a Netflix subscription.
Yeah, and you want to give it to your daughter so that she can use it.
Yeah, I mean, I don't have a daughter, but yeah, I mean, assuming. Yeah, or anybody else.
Blockchain cannot do that for you.
No, so I'm saying, can I, like the fractional ownership and so on, can I lend my asset to somebody and get it back is my point.
Well, I think one of the promises of blockchain is that your subscription could be an asset. And then if somebody wants to build some kind of system that allows you to do that and build a product out of it, well, they can. So I think that's one of the things that is possible with this kind of system, sure.
Blockchains are not a database. They are a platform for transactional data. Having said that, streaming and the way streaming interacts with the user base, we have an interesting, by the way, Indian use case, Xfinite, where actually Eros Group, Kishore Lula, does let's say, the motivation of the community, like with a fidelity point, okay, via blockchain. So, okay, I'm seeing the Bollywood movies that this producer creates I consume his content, but I'm giving him some of my attention span. I'm giving him a like or a dislike to the movie. I'm giving a comment on the movie, a gossip on the star of Bollywood that is I saw at the bar at the corner with someone that isn't his wife, and so on and so forth. He remunerates you with a token. So there is a change of what is possible, goes beyond the fact of sharing or having fractionalization of ownership and so on and so forth. There is the ability to represent value in a different manner, and also the logics of the platform of social network can benefit from that type of representation, which I think is interesting for economists.
So I got a question to both you and Henri. So one thing that I always thought of is that zero knowledge proofs are quite time consuming because you have to have probabilistic, but it takes some time to verify. So and that's the general trade-off with the normal verification transaction. So can you give us a sense of how long that would take? I mean, so for instance, on Ethereum, I understand if you wanted to run it on mainnet Ethereum, it also costs a lot, like 1.7 million gas or so, right? So what do we have to expect if I were to use your network with CBDC? What's the time delay of me making that transaction?
Sure, that's a good question. I think there's an overhead in generating a proof, sure. But you get to figure out that the difference between a blockchain network and a zero-knowledge proof network or a validity rollup is that you don't need everyone to do the same computation. So in a network where you want a lot of actors for it to be decentralized and it to be credibly viable, you have a lower limit on the kind of capacity of machines you get. With zero-knowledge proof and validity proofs, you're basically able to use the output of a supercomputer and use that in your base layer. So you can scale way higher the machines you use to perform computation. So that's the first answer. The second one is that, say you're using a CBDC, probably there's a lot of the workload you can parallelize. And the relationship between verifying and executing is, if the workload is T, the verification is log T, so it scales exponentially. So if you cut your T in, say, like 8, and you generate 8 proof, and then you generate a further proof with those 8 proofs, then you're able to save a lot of time in the execution compared to if you were doing a single proof. Right? Does that answer your question?
Yeah, it does.
Henri, one quick thing to Henri, and apologizes. You didn't name some of the big boys that are using your stuff like the other two, so is there anybody using it today?
Yeah, so I mean, decentralized systems such as DYDX, Sorare, Immutable, GameStop, it's mostly Web3 native ecosystems.